Today we're going to look at elimination reactions. We're going to see two different elimination reactions, E1 and E2, and we're going to see how those compete against each other and against SN1 and SN2 reactions. First, let's look at an E2 mechanism. 2 means there's two molecules involved in the rate determining step. One of them is the big molecule I drew here, and the other one is, let's say, a strong base, methoxide. And since this is an elimination reaction, let's look at what gets eliminated. One, this iodine. It's going to come off and become an iodide. It's a big atom, so it makes for a good leaving group. And since we're forming a double bond in this reaction, another atom has to come off. And in E1 and E2 reactions, that's a hydrogen. So that could either be a hydrogen on the carbon neighboring this carbon on the right, or it could be a hydrogen neighboring on the left. The fact that we have a strong base, methoxide, here indicates that the E2 reaction mechanism is going to be favored to E1. What this strong base does is it attacks a hydrogen and starts to rip it off. From where I drew the methoxide, I bet it looked like we were going to do this, but that would be an SN reaction. I mentioned in class that an elimination reaction is kind of like an SN reaction gone wrong. In an elimination reaction, the base attacks a hydrogen on a carbon that neighbors the carbon with the leaving group. So I'm going to redraw a hydrogen over here. The base could attack any of the three hydrogens on this carbon on the left, but I'm going to just draw one for it to attack, and that would look something like this. We know there's a negative charge on the oxygen. The hydrogen here has a partial positive charge. It's a match made in heaven. So the strong base rips off the hydrogen, and as it leaves, its electrons stay with the carbon here, and they end up getting shared with the carbon with the leaving group, and the leaving group goes ahead and comes off. So note here that this base methoxide kind of pushes electrons all the way from the hydrogen through to the middle carbon and through to the leaving group. So it's kind of one big long process where the effect of this base 5 atoms away from the leaving group can actually really help the leaving group leave. Okay, so let's look at the resulting product from that mechanism. The double bond is formed between the two carbons on the left. This is not the most stable possible product that can come out of an elimination reaction, because the base could have also attacked the hydrogen over here and created a more substituted alkene, a double bond where the carbons have more carbons bonded to them. I redrew this molecule a little bit so we can see a reaction where the base attacks another hydrogen and a different double bond is formed and the leaving group comes off in a similar way, and a more substituted alkene is formed, and that is a more stable product, which means in this case that the transition state leading to this product is more stable, which means that this reaction happens faster than the first one we saw, which means that this is the favored product. And that means we'll probably see a lot of this and a little of this formed. So that was an E2 reaction. Let's look at an E1 mechanism. Let's change the nucleophile to a weak base. And I've done that here. We have methanol instead of methoxide. The negative charge is gone, so it's significantly weaker. But the oxygen still has lone pairs that it can donate. And let's make another change. Let's change the starting molecule to this. Now, if this iodide were to come off before anything else happened, it would leave a tertiary carbocation. Remember, that's the most stable kind. So this molecule has no problem doing that. And that's actually what happens in the first step of an E1 reaction mechanism. Now that a carbocation is formed, that positive charge wants to pull in electrons, and that makes this hydrogen here easy pickings for our nucleophile, even if it is a weak base. And the result of this is the same product that we saw in the E2 mechanism. Well, it would be the same if I hadn't added this methyl group up here. But anyway, the E2 and E1 mechanisms both do the same thing, but in just a little bit different way.
Made with Doodlecast Pro.